Welcome back, guys. Today's question is prime factorization of a number using Sieve of Eratosthenes algorithm. In previous video, I talked about classical Sieve of Eratosthenes to find whether the number between range from 1 to n is how many numbers from range 1 to n are prime. And we could actually use this to determine the factorization of a particular number that are prime. So, what we will be given in questions, right? Uh, we will be provided question in query format. For example, we are provided with let's say 10 queries, and we need to compute the prime divisors, means prime factorization of those 10 numbers by using this sieve of Eratosthenes algorithm. If we think of a naive solution, first of all, we will be looping from all those queries, 10 queries, let's say, and then we will be dividing each number with starting from 2 to the square root of that particular number, and then checking out if that particular divisor is prime or not. So it would take us a lot of time for doing that naive solution. So let's optimize this by using this algorithm. First of all, what we will do is we will declare the an array of a boolean array, or you could consider an int array of the maximum constraint that we will be providing in a question. Here it is 2 into 10 raised to 5. So we have declared an array, a global array for the class as max plus 1. We will be marking the smallest prime factor that divides our number, right? For example, uh, if a number is marked, let's say 16, which means 2 is the smallest prime number that divides 16. 17 is marked 17, which means the 17 is 17 itself, the number that divides itself, and it's the smallest. We could use this particular thing in fetching out what particular number divides the particular our query number in smallest time in, and we can fetch from that black box in big of one time, means constant time. Let's fill up this array. First of all we will mark all those number with the number themselves, and for the second iteration we will be um, iterating our outer loop to square root of the maximum number, because we don't know at what is the maximum size of our queries. So we'll be preparing our arrays of the maximum value given our constraints. Now we will be moving in the inner loop only if that particular number is marked by the number itself. If that particular number is marked by its previous number, which means that it is not prime and it is already marked by some previous number, so we will not iterate an inner loop for that. In first iteration, let's say it's 2, so 2 is marked by 2, and we'll mark all those numbers that are divisible by 2 with number 2, which will be handled by our inner loop. And this condition SPF of j equals to j, which means that we will for the next iteration we will only mark those numbers that are marked by the number itself. We need to check it second time, because let's say for 2 that are divisors of 2 are marked by 2. Now when it's a chance of 4, or let's say any number, let's say 3 is marking 15 as its divisors. Now when it's turn of 5, so 15 is also divisible by 5, but it is already marked by 3, so we need not to mark it again by 5. So we will leave it and not mark it and move to our next iteration. So all those functions are handled by our inner loop and outer loop combined. At last, what we will be getting is, for all our array, we will be we are able to fetch the smallest prime factor that is divisible, that divides this number in big of one time, means constant time. So what our task is left? Our task is left what to iterate all the queries queue. In this particular geeks for geeks question, it is not in query based, it's simply given a number, but let's assume that we are provided with queries so that we are able to utilize this sieve function more than once. Now let's consider one of the queries. We will be iterating a while loop till our number becomes 1. We will be checking from our maintained array We will be fetching that prime factor, smallest prime factor in big O one time, as we discussed previously. We will be adding that prime factor in our list, and we will be simply dividing our number with that particular factor until it is divisible. The moment it is not divisible, we will be moving to the next number. And what number that would that be? It will be our remaining, means remaining n, left over n. We will be again fetching it from the array, and we'll check what smallest number divides it with a smallest factor, and we'll be again performing this inner while loop until it divides and meets our requirement. And we will be performing this outer while loop until n becomes 1, and we'll simply return that array list. And this is how our questions will solve. It will be highly optimized. Let's check out the time complexity. We already know the Sieve of Eratosthenes gives us time complexity of n, logarithmic of n. It is proved by the scientist who discovered this, who researched upon this, so there's no need to check how this complexity is derived, and no interview will be asking you this question. The auxiliary space is almost big of n, because 2 into 10 raised to 5 will be our maximum array size. We could optimize further this by considering the maximum of the number that are provided from all the queries, and we could declare it in that way. But for simplicity, let's keep it 2 into 10 raised to 5. So the overall time complexity for the Sieve function is n log of n, and this while loop keeps iterating till logarithmic of n. Why? Because division function handles our requirements for logarithmic of n, right? So if let's say we are provided with q queries, so our overall time complexity will be n into logarithmic of n plus q into logarithmic of q base 2. See you in the next question. Bye.